Hey guys, today we're going to start notes for our statistics chapter. You have already done a little mini project regarding analyzing the size of different data points from a farm. So you looked at the size of crops of peas. So hopefully that gave you a taste of what statisticians need to do to answer questions. So the first thing we are going to do after that introduction is we are going to discuss some vocabulary regarding statistics. So these are all in the text, but you might want to just write them down yourself so that you can kind of internalize them more. So a population is a collection of individuals about which we want to draw conclusions. And it doesn't even necessarily have to be individuals. It could be the peas, measuring the size of the peas is the population that we're looking at. But in general, if the statistics are about people, it's the collection of those people which we're studying. A census is if we are taking information from the entire population. So this is very apropos for what's going on today, because today, this day and age, we are looking at collecting a census from all United States residents. So census means we want to talk to everybody. So it is the whole population. They do want to discuss everyone's household situation when they do a census. So census means everyone, whereas sample is just a subset of the population. So mostly when they do statistics, they do them on samples of people. So for example, if they say 25 million people watch the Super Bowl, they didn't actually talk to 25 million people. They surveyed a sample of the United States population. Generally, it's around 2,000 people about their TV watching habits. And then they base the numbers on, well, what percent of that 2,000 people watch the Super Bowl? And then they apply that to the whole population. So in general, statistics is more done with sampling than it is with a census, because a census requires you to talk to every person, and that is very tough. But a sample is more achievable and actually gets very similar results to if we have done the entire population in the census. A survey is how data is collected. So generally, when you do a survey, it's a piece of paper, or it's a person asking you questions, or it's a form online. And that's a lot of times how they collect information. They can also collect information by observing people, by testing people, by, that's generally it. But the survey is a lot of ways how people gather statistical data is by asking people questions. Either in person, online, or on a paper survey. And data is the information you get from the survey or the observation. Okay. So the data for a census would be, for example, your name, your age, your address, how many people live at your house, and other questions that they may ask about you during a survey or during a census. Okay, so those are some key statistical concepts. Continuing on the next slide, a parameter is a numeric quantity measuring some aspect of a population. So not all questions in a survey are going to have parameters, such as what is your gender? Where do you live? What's your favorite color? None of those can be assessed with a numerical quantity. So some numbers or some survey questions can be described by parameters such as age, height, weight, number of people in the household. Those are all numerical quantities. So if a survey question can be expressed with a numerical answer, it is considered a parameter of that population. And a statistic, as you can read, is a quantity calculated from data gathered from a sample. And it's usually used to estimate a population parameter. So a statistic would be the average age of person in Milwaukee. That's a statistic because it is a calculated quantity from data gathered from a sample. You could also do the median home price in a certain, like Bayview, for example. That is a statistic. So it's when they take all of the data and they try and summarize it in a concise way. So they don't say, oh, the houses in Bayview cost, and then list every single cost of every single home. That people can't take that in. You need a precise way to describe a parameter, and that is using a statistic. So some examples of statistics are the mean, median, and mode. A distribution is the pattern of variation of data. So let's say we were graphing here the ages of teachers at Brookfield Academy, not to name actual ages, but they could be symmetrical, where let's say in the middle you have, I don't know, 45, 50 in the middle, and you have some younger than that and some older than that, and about the same amount that are younger than the average are the same as the amount of people that are older than the average. That would be a symmetrical distribution. It's schools not like BA. You can have a positively skewed where, let's say this is 45 years old. Most people would be younger than that. That's positively skewed. Whereas if we look at 45 and you're talking about the age of teachers at a college, that's going to have a negative skew because the teachers at the college tend to be older. So you have few young professors, here's 45, and then a lot more older professors. So symmetrical data is where you have about half above and about half below the median or the mean. And that's what the distributions look like. So please remember this little diagram of symmetrical, positively skewed, and negatively skewed, because you're going to be asked about this in future homeworks. And lastly, for our vocab, we have outliers. Now, an outlier is a data value that varies from the rest of the data. So, for example, if for height, if you have someone that is much taller than everybody else in a population, they are considered an outlier. Likewise, if someone is a lot smaller than most of the people in the population, that would be considered an outlier. Now, there are a formula to determine if something is in fact an outlier, but in general, you kind of know. It is data points that stand out, data points that are unusual, and those are called outliers. And they should be included in an analysis unless it is a result of human or other error. In general, unless you decide to discard your outliers. But again, if you see something strange, you definitely want to check to make sure you didn't make an error in your measurement. Like when I'm typing in grades, let's say it's out of 50 and someone got a 45, and I actually wrote down instead of 45, 15. That would be an outlier, but that's because of human error. So that outliers help you to pay attention to your data entry as well. All right, so some terms regarding statistics. Discrete data are data that can be collected by counting. So you have to consider discrete data are things that can be counted. You know, you have them sitting there. How many pairs of shoes do you have? Those can be counted. So things that start out with how many are generally discrete data. Continuous data is how much, how high, how tall. There are things that can be measured. So, and it can be any number. So continuous data, for example, height is a continuous data. because I am 5 feet 7 inches tall. I shrunk a little. I used to be actually I'm 5'7". I used to be 5'8". But I could say I am 5 feet 7.263987 inches tall. My height can be really any number. It just depends on how precise I am with my measuring. And it is measured. Height is measured. So it's continuous data because it can be any number within the range of reasonable. So height is continuous because it is measured. Age is actually also continuous because you could be like, you guys are all 17, 18. I'm trying to think if we have any 16-year-olds in there, but 16, 17, 18, you can be 17.875 ... years old. So age is continuous. Population is counted, okay? So we count how many people there are to determine a population. So that is counted. That can't be any number. Population are all whole numbers, okay? What's the population of Brookfield? What's the population of Brookfield Academy? What's the population of Europe? Okay, those are all counted. Number of siblings are counted. Time it takes to school, that is continuous. That can be any number, 45.2387 minutes. You know, it just depends on how precise you want to be with your measurements. Do you want to have a stopwatch that goes super far in detail? So continuous data is data that is measured. So here's just an example of what data will be discrete and what will be continuous. Now, depending on whether the data is discrete or continuous, that will tell you what type of diagram or graph you want to use to describe the data. If you have discrete data, you're going to use a column graph. If you have continuous data, you are going to use a histogram. Okay, so they look similar. I should probably change this. So discrete data, I don't know what I was thinking here, can be described using a column graph. Continuous data is described using a histogram. There we go. That's better. And then you can tell the differences. Column graphs and frequency histograms both have the following features. The frequency of occurrence is on the vertical axis. So that, you guys, is right here. Frequency is both on the vertical axis right there. Let's get to this. So frequency is always the vertical axis, and frequency means how many. Okay, so how many people have 0 siblings? How many people have 1 sibling? How many people have 2 siblings? So frequency means how many. And on both these graphs, it's going to be on the vertical axis. The range of scores is going to be on the horizontal axis here. So if it's like number of siblings, here they are. And notice for number of siblings is going to be discrete because this should be a whole number here. So the range of scores is on the horizontal axis. The column widths are equal and the column height represents frequency. So the column widths being equal means that here to here is going to be consistent for all the bars. And here to here is going to be consistent for all the bars. An example of continuous data, as I said, is going to be height, or anything that is measured in inches. And the way that works is on the horizontal axis, we have frequency, so the number of people. And on the vertical axis, let's say we go to 60, that's 5 foot tall, 62, let's say 62 inches tall, so 5 foot to 5'2". If you are anywhere from 5 foot to 5'1.99999, you'd go in this first column. And then if you're 5'2" or above, you'd go in the second column. So if you are in the 62 inch, so that's 5'2" or taller, you would go in the second bar, not in the first bar. So if you're on the border, you always go to the right. Now the column graphs don't have that problem because the data is not continuous. You either have 0 siblings, 1 sibling, 2 siblings, 3, 4. If we count half siblings, you just have to decide how to handle those because people can't be half a person. So that's why it's continuous, or it is discrete data. Okay, so that's how those look. So the main difference between the column graph and the frequency histogram is the column graph, the columns do not touch. The frequency histogram, the columns do touch. And the reason they touch is because you can be anywhere in this continuum, 60 to let's say 78 inches tall. You can literally be anywhere. Whereas when you're considering number of siblings, you can have 1 or 2 or 3 or 4 or 5. You can't have 3.6 siblings. Okay, there's nothing inside there. So that's why the columns don't touch for a column graph, is because it is discrete data. So on your own, in the textbook that I have uploaded to Google Classroom, I'd like you to read the case study on page 378 through 379. It goes into how to create a histogram given this data, which is data on how far this person, Ethan, drove the golf ball while he was practicing. And so it goes through how to do grouping. One thing to point out is when you do grouping, you want to group the data in between 6 and 12 groups, because each of those groups will represent bars in your histogram. So that's that. Right now, we're going to go through data of our own. So we're going to create our own histogram. So 20 people were asked to state the number of hours they exercised in a 7-day period, and the results of the histogram are shown down here. So this is how many hours they exercised in a 7-day period. So if we look at this, I have data that has a maximum of, let's see, it looks like 19 hours is my maximum, and a minimum of 0 hours. Okay, so minimum of 0, maximum of 19. So that means my range, which is my maximum minus my minimum, is 19 minus 0, which is 19 hours. Okay, and we want to break this up into equal intervals so we can develop our different, what are called bins, which will become our bars when we go ahead and do our histogram. So if we do, let's say just 0 to 20 to be nice and neat, I could have from 0 to 20, I could have intervals of 2, I could have intervals of 4, but intervals of 4 would yield not enough of these. So I'm going to do intervals of 2 here. So what that means is that I'm going to have between 0 and 2 is a class. So 0 hours to not quite 2 hours. And then another class will be 2 hours to not quite 4. And by not quite 4, I don't want to draw, I got to get rid of that little line there. There we go. Not quite 4. So what I want to do is figure out of these numbers, how many are between 0 but not quite 2. So this is between 0 and not quite 2, 0 and not quite 2. It looks like for that one, I have my tally for that there are 2 people that went to the gym between 0 and not quite 2 hours. Sorry, my highlighting was a little off. So 0 to not quite 2 hours, my tally is 2. All right, and I will need to erase just so I have a little more room. And again, I could make my intervals bigger or smaller, but if I'm going for between 6 and 12 different categories, if I did intervals of 1, there would be too many categories or too many intervals. And if I go like every 4 hours, I'll have a little bit low on my intervals. So it's going to be 4 to not quite 6 hours, 6 to not quite 8 hours, 8 to not quite 10 hours, 10 to not quite 12 hours. I don't need that line to be that long. And then keep going, 12 to not quite 14 hours, and then 14 to not quite 16 hours, 16 to not quite 18 hours, and 18 to not quite 20 hours. Okay, and then within each category, within each interval, you want to find the people that went that many hours. So 2 would be in that yellow category. And then let's see, 2 to not quite 4. I think that's it. There's only 1 there. Hopefully I didn't miss one. And then 4 to not quite 6 hours. That's going to be 4, not 6, because that's going to go in the next category. And then 5. And then, am I missing one? 4 and 5. Okay, it looks like 2 in that category. And then 6 to not quite 8. That's starting off at 6. And then 6 to not quite 8, we have 6, 7.5, another 6, but not quite 8, so I wouldn't include the 8. 6.5. So we have 1, 2, 3, 4 in this interval, which is 6 to not quite 8. So greater than or equal to 6, but less than 8. So 1, 2, 3, 4 people in that category or that interval. And then we have 8 to not quite 9 or not quite 10. So that's going to go here. 8 to not quite 10. So 8, another 8. Another, or a 9. So we're going to not quite 10. So it looks like in this category, we have 3. And again, the goal is with these intervals, I should have between 6 and 12 so I can properly summarize my data. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 categories or 10 bins. And again, if I would have done every like 0 to 1, 1 to 2, it's too many. But if I do by 3s, that could have worked as well, but those numbers are a little weird to work with. I don't know, I just felt like going with even numbers are better. 4 would be too few. Okay, so let's go 10 to 12. I think I'm running out of highlighter colors. So I'll choose, let's see, smiley faces. So 10 to not quite 12. We have 10. To not quite 12. because 12 will go in the next category. Okay, 10 to not quite 12. 10, 11, 11, 10.5, that's 10, 11, and anything under 12. So 1, 2, 3, 4 of those. That's pretty common. Okay, let's do a little rainbow stamp. Okay, 12 to 14, 12 to not quite 14. So we have 12. And there we go. I think that's it for those. So there's 2 of those. 14 to 16, I'll just grab a crayon. Do this one in green crayon. So 14 to not quite 16. Ooh, here's the 15. Right there. Yeah, looks like I'm covered there. There's just one there. 16 to 18, I think that's nothing. 18 to 20, I have 1 there. This is my 18 to 20. And then it says that I talked to 20 people, 20 people. So I'm just going to count up, make sure I have 20. So this is 5, 9, 10, 11, 12, 16, 17, 18, 19, 20. So it looks like I counted everybody. So that helps me to know how to move forward. Now I want to create a histogram with this data. So a histogram has the frequency on the y-axis. So frequency is a way of saying the number of people. So the number of people, and I have these lines here to represent 0, 1, 2, 3, and 4, because that's the number of people in each category. And then when I go to make my data, my minimum was 0, and then I went up by 2s. So this is going to be 2, 4, 6, etc. Now these should be evenly spaced. I'm winging it a little bit here. Hopefully it won't be too bad. All right, now I'm going to draw lines. So 0 to 2. Oh, I'm going to split screen so I can see our data here. Okay, so here we go. 0 to 2, I had 2 people. So from 0 to 2, that bar, ooh, I'm going to color code it, you guys. Here we go, 0 to 2. 2 people went to the gym between 0, but not quite 2 hours that week. So anywhere between 0 hours and 1.999 hours go in that category. Then 2 to 4. 2 to 4 only had 1 person. Okay, and that one was the yellow highlight there. So there was 1 person. This is a histogram, so the bars need to touch because this is continuous data. 4 to 6, we have 2 people. And that one I represented with orange color. Right there, a little messy, but you guys get the picture. 6 to 8 had 4 people in it. And that one I represented with the green highlighter. Okay. 8 to 10 had 3 people. Ooh, that one I made a little skinny. You'll have to excuse my lack of spacing there. Okay, 8 to 10, 10 to 12, I had 4 people again. So we're kind of seeing what the majority of the people interviewed at the gym did. It looks like we're at majority land right here, where the majority of people were there anywhere between 6 and 12 hours, because these are our biggest bars here. Okay, and again, because the data can be any number, it doesn't have to be a whole number, the bars touch. Between 10 and 14, we had 2. And that one we had rainbow. (14) and 16, just 1. Okay. 16 to 18, we had 0 people doing 16 to 18, so that doesn't get a bar. And then 18 to 20, there was only 1 person that went to the gym or worked out between 18 and 20 hours. So I'll just color this in with, we'll do something fun. For the superstars that were working out that much per week, there we go. Okay, so that is a histogram. The only thing I need is labels. So I already labeled my vertical axis. This is the number of hours working out per week. And then you can give it a colorful title, like work at. Okay. So that's our histogram. Again, the y-axis will always be the number of items that meet that category. The x-axis is what you're measuring, and the bars must touch, and you should have anywhere between 6 and 12 bars. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would have had a 9th if we had any people in that category. So that is a histogram. So hopefully that helps you to learn how to read one and how to set one up. Okay, here is the homework, 14A in your packet. You're going to do numbers 10 through 19. So for 14A, we'll go there in a second. 14A. Sorry, 14A, you're going to do all the problems. I don't know what I was talking about. 14A, you will do all the problems 1 through 4. All right, you guys, just email me if you have questions, and that's it for today.